Okay, so I'm going to talk to you about systems Aikido, so an approach to working with biological systems, novel engineering approach. I wasn't expecting this slide to be here for 20 seconds. So. Okay, so lots of the problems that we face today as a society are about dealing with complex adaptive systems, systems with lots of interacting parts in which the components tend to evolve, and they often have unexpected higher-level behaviors. So these could be ecosystems, financial systems, global climate systems. A lot of them are ecosystem-like systems. And when we want to engineer or interact with these systems, we're not interacting with static artifacts. We're interacting with biological processes, and our engineering approaches need to reflect that. So why? Because ecosystems are complex, and often when we intervene with them, we get unexpected consequences from indirect effects. So, for example, push for biofuels and planting of more biofuels led to spikes in global food prices via a variety of interconnected systems. Biogeoengineering, if we try to sequester carbon by sprinkling the oceans with iron filings, people have suggested that we might provoke algal blooms and damage marine ecosystems by indirect effects in these ecosystems. We don't know. We can't predict what will happen when we intervene. Natural systems have their own powerful physical dynamics. A lot of our technologies are very energy intensive because we constantly try to work against these systems. In agriculture, we constantly plow, we work every year to put the ground back to a state which is essentially working against what the land wants to do. The land wants to move through succession and turn back to forest. We put work in to keep the ecosystem at the early stages of succession. Good conditions for annual crops, perfect conditions for weeds also. Constantly having to put in work. So what do? Well, we want a new approach which is based on Aikido rather than karate. In karate, we put our energy, our strength, and our force into working against our opponent. It's energy intensive. And this is the way we're currently working with biological systems. When we start to do karate, we use our opponent's energies against them. Our opponent will run at us, and we'll use their momentum and their strength, intervene with them, tip them, and use their strength against them. This is the kind of approach that would be sensible for complex biological systems. So systems Aikido. I'm going to talk to you about some work. I spend my time trying to look at this kind of approach in biological systems, which are bacterial biofilms. Most bacteria on the planet live in complex cooperative assemblages. They're not single cells. They build structures in which they live. They're in every ecosystem. Here they're around plant roots. And they are key players in biogeochemical cycles globally. We need to be able to interact properly with these systems. And they cooperate. They have cooperative behaviors to build their structures, to metabolize food, and to promote resistance to antibiotics. These biofilm structures are extremely resistant to antibiotics. So understanding them and interacting with them properly is very important. This is 90% of all bacterial life in this form, not as we work with it in the lab in a planktonic culture. Okay, so these systems can evolve. What bacteria do best is evolve rapidly to changes in their environment. All biological systems evolve, but when we try to deal with bacteria, we've been constantly pushing against their capacity to evolve. We've been using antibiotics in large numbers, and ultimately, we've ended up with a situation in which we have highly antibiotic-resistant bacteria, effectively trying to use a karate approach to dealing with biological systems, which is ultimately counterproductive. We've ended up in a difficult situation. So in order to deal with them in a more intelligent way, we've been trying to look at manipulating how they cooperate, using what we know about when cooperation evolves. It's a very long slide. So cooperation can be difficult to evolve. Imagine you're grazing cows on a pasture. The sustainable level of grazing is 2 cows per person. So if everyone cooperates, the pasture goes on just fine. But in this situation, it's very common that people will start to graze 3 cows on the common because they get all the benefit of cheating and they share the cost with everyone in degrading the resource. This is what's called a tragedy of the commons, and it's a very common evolutionary dynamic which prevents cooperation from happening. But, however, we know that if evolution happens in group structures, cooperation can be stable. There are some magical experiments in which groups of chickens were evolved as a whole for egg production with massive increases in the number of eggs that a whole group of chickens could produce. Whereas if you select a single hen from a group, you actually get egg production going down. We've used the same approach, basically evolving sociable and synergistic communities of organisms by changing the group structure with which we look at those organisms to evolve soil microbial communities for soil regeneration in arid conditions. We've also used the opposite. We try to engineer a tragedy of the commons by changing the environmental conditions around bacterial biofilms and infections so that cheating is promoted and the biofilm will break up of its own accord. So we try to change the conditions, the evolutionary conditions in which the bacteria are evolving. So the idea of this approach is that rather than trying to push hard against the bacterial systems, we change the environmental conditions, we change the context for evolution so that what we want the bacteria to evolve to is what they want to evolve to. We can't win against bacterial evolution. So this is systems Aikido, the first steps.